moment around O, but now there'll be two pieces of it. Okay, so in our diagram here, we have the origin. That's where we want to find the moment about. And in this case, we have two forces that are being applied at A. One of them points towards this point B, and one of them points towards this point C. So there'll be a force directed from A to B, and a force directed from A to C. So the force from A to B is labeled here as FB, and they tell us the magnitude or the tension in that rope is 780 newtons. And the force directed from A to C, they're calling FC, and that has a value of 420 newtons. So we're in 3D here. So on this diagram, it's going to be helpful to put all of our coordinates. So B is located at 0, 2.50 meters. A is at 006. The origin is at 000. And C, negative 30. Any questions on the diagram here? Yeah.
I don't have a question on the diagram, but on these you don't have to do a given step. I think you weren't given much, but...
Right. I mean, if you want to follow the same, basically the same format as we have been doing, then right, I would say stick with that. These processes are a little bit different because it's not an equilibrium question, but most of the steps will be the same. This will be just diagram rather than FBD, and you still will basically have an equation and solve steps. Yeah, if you want to keep that format, then that's good. Yeah, so given all we really know is that we have the diagram. All right, so now we have a full diagram that we're going to use, so we can jump to our equations that we're going to use. All right, so ultimately, where do we want to end up? Well, that find step, so how are we going to, maybe we can't at the very moment, find the moment around point O? What will be the elements involved in that calculation? Yeah.
Moment around O from force B and moment around O from force C.
Right, so at least conceptually, each force is going to contribute to the moment around point O. So right, FB and FC, each force individually will. So how can we represent the moment contribution, let's say from the force B? What would we write up here to designate that? Or how are we going to calculate that part of the moment? All right. In this case, it's named FB, so I'll just stick with that. But right. All right. So it's called FB, so I'll just stick with that. Vector FB. So what we're using is the position vector. Again, still points from the point we want to take the moment around about, so that point O, to the point where the force is being applied. FB is being applied, even though it's named FB, it's being applied at point A. So that's why we're using that ROA as our position vector. So ROA cross FB will tell us what moment is produced by vector FB around point O. Right? And then what do we have to add to that to get, again, the total moment around point O? So in this case, this will not always be the case, but both FC and FB act at point A. But you could have multiple forces acting at different places, and then those position vectors will be different. This one happens to use ROA for both of them, because they're both acting around O and acting at A. Or we want the moment around O and they're acting at A. So we need ROA, we'll use that twice, we need vector FB and vector FC. So at the moment, do we know any of those three values to be able to do these cross products? Yeah.
You get the notation for ROA.
Right. So to answer the first question, at the very moment, we don't know any of them. So we have to find them in order to get to this step. So basically, we just have to fill in the things we don't know using methods that we already do know. So we can start with ROA. That'll be the easiest to get to. So how can we calculate ROA?
6K.
Right, it's just 6K. It's the end point minus the start point, just as we've seen before. So 006 minus 000, 6K is ROA. So that step is easy. The rest of them will not be quite as easy. All right, so ROA is taken care of in both locations. So let's look at FB. Do we know vector FB? What do we know? Right, we know its magnitude. We don't know the components of it. So what's this going to be equal to? Or how can we construct a vector? Yeah.
FB all the unit vector times FB for I.
Right. So generically, what do I want to write here? I want to write its magnitude, which actually we are given, times its direction. So what is the direction of vector FB? Or U hat sub, what are the subscripts going to be here? Right, AB. So again, this designates the direction of force FB. It points from A towards B. So notice point B and C did not appear. That has nothing to do with this R. B and C have to do with the forces because we need to know their directions. So this is where B and C are going to come into play. FB, we were told off the bat, was 780 newtons. So we need to find U hat AB in order to find vector FB. So how are we going to find U hat AB? You should know this right away because this is the homework that's due Thursday. So just in variables, how do we calculate U hat AB? Yeah. Right, so the position vector RAB divided by its magnitude. We normalize the position vector that points from A to B. So vector RAB is going to be endpoint minus start point. So 0i, 2.5 minus 0 gives us 2.5j. And 0 minus 6 gives us minus 6k. Calculating the magnitude of this, it has a magnitude of 6.5. So this actually works out to a nice fraction. We're going to get that U hat AB is 5/13 j minus 12/13 k. So now we can put it all together and get FB in its component form. Again, we were told its magnitude was 780. We just found U hat AB, 5/13 j minus 12/13 k. So we just multiply that scalar by this vector, and we're going to get FB in its component form is going to be 300j minus 720k, and that's in newtons. Questions on this step? So FB, I'm just writing it in the component form given its magnitude and I found its direction. So we still need FC, same process. FC is going to be its magnitude, which we're told was 420, times its direction, U hat, it points from A to C. Right, so positive 120I, minus 180J, minus 360K. And that's in newtons. And if you want to do the intermediary steps, U hat AC, you should have gotten 2/7 I minus 3/7 J minus 6/7 K. And then multiply that by the 420. All right, so we have FC in its components, I, J, K form also. So that's done. So if we look up here, we know all four of these things, well, three things, in their component form. So now we can proceed to the next step. So we can now write these using the determinant. So ROA is going to be 0, 0, 6. This is in meters. And the components of B is going to be, we have it down there, 0, 300, negative 720 newtons. And now we want to expand this cross product into its determinant. And the components of FC, this will have all three. So 120, negative 180, minus 360. Again, this is where we do want to make sure we have consistent units here. If one of these was for some reason in millimeters and this was in meters, then this cross product will give us Newton meters. This one will have given us Newton millimeters. So this will be a good way to check to make sure we have the same units so we can add them together as we want. Right, so we have two cross products here. So each one we're going to expand into its cofactors and then put it all together. So once we put into their cofactors, right away you can make some simplifications. If you look at the cofactor here, here, and here, anytime in a cofactor you have a row of zeros and or a column of zeros, the cofactor is going to be equal to 0 because, for example, 0 times something minus 0 times something is going to result in 0. So you can go through the whole process and get that, or just recognize that pattern. So three of these right away are going to go to 0. So if we look at, so what's the cofactor we got in front of the first term? Or the answer to that cofactor? Right, so negative 1800. So 0 minus 6 times 300, and that's I. That's 0, that's 0. Here we'll have another I term. So this is going to be 0 minus negative 180 times 6. So what do we get here?
1080.
Right, positive 1080 I hat. And then this j term is non-zero. So we'll have 0 minus 6 times 120, but negative times that. So what do we get in front of the j? 720. Positive 720. We have two terms that have I in it, so we're going to combine the like terms. So this results in negative 720I plus 720J, newtons times meters.